Okay, so we'll continue to step number 17. There is mission planner setup. For these steps, for now, I have disconnected the repeater tube signal. Alright, for your note. We will connect later when we assemble with the aircraft. Main integration for the flight controller to the airplanes. Okay, first 17.8, connect USB cable from PC to the flight controller. So connect this USB cable to the flight controller and then connect this to the computer. So we can, after we have downloaded the mission planner, so this is the mission planner software. Okay, so we'll go, this is a 7.3.70 versions. Okay, we'll go to the select suitable COM. So we'll select here COM12 as shown here. It is detected as Arduino Mega 2560 COM12 and select the baud rate as 115200. This is for the cable. So click connect and wait for Mavlink to connect between the mission planner and the flight controller. Okay. Next, if you want to upload the Arduino firmware, we can go to the initial setup. Okay, install firmware here. So if you want to install the firmware, we can install by disconnecting the connection first. Okay, so it is shown here. We can upload firmware that is shown. So ours is airplane, so we can upload. So if you want to, you can upload, but it will take time. So for now, we will not upload the airplane's firmware because it is already uploaded in the flight controller. So again, we just connect it again as previous steps. So how we want to know that it is in fixed wing firmware? We can check here in status. It is now COM12 and it is in with a fixed wing firmware. Okay, ours for our case it is an airplane, so it is a fixed wing. Alright, so we want to see the HUD over here. We have the airplanes and the map. First we could look at the HUD. This is disarm and fail safe because we didn't turn on the transmitter, so we'll turn on the transmitter here. So it is the fail safe warning is not shown anymore, so we have turned on the transmitter. So we'll follow the next step. Initial setup, mandatory hardware. So go to initial setup. You can download this software to your PCs, but you cannot see if you're not connected to any of the flight controller. You cannot see this, but still you can do something with the firmware. Accelerometer calibrations. So we'll do calibrate accelerometer. So we have our flight controller attached together with the receiver and GPS over here. So our forward arrow is parallel to the GPS and compass. Right, it's connected. So we want to calibrate accelerometer. Okay, we'll click here, calibrate accelerometer. Okay, it will show notice there and we'll follow. Place vehicle level and press any key. Alright, this is now level. Then place vehicle on its left. Okay, it's left. And click done. And then place vehicle on its right side. So right side, click done. So then it show place vehicle nose down and press any key. So this is nose down. So place vehicle nose up. Okay, place vehicle on its back. So this is for accelerometer calibrations. Okay, so it's showing calibration successful. That's good news for us. And now next is calibrate level. So just click calibrate level and it will show it's completed. Next, 17 D, in the setup, compass calibrations. We'll go to compass calibrations. Okay. So we look at calibrations, APM, and external compass. Let's try this. Okay, this is the compass. Okay, say it's none. And then click live calibration. Okay, so at this stage we need to turn the flight controller and together with the compass. Aim for the white dot. Please point the autopilot knots. Our knot is there. The back. Rotate around the pitch axis until level. Then turn the autopilot 90 degree and rotate. Turn is like this and rotate around the roll axis at the level. Or you can push it like this, put it and until you get the dots. Okay, my cable is stuck. Right. Okay. Because we select this as use auto accept, so we need to move more until it gets sufficient data for the GPS. Okay, in this procedure also we need to move away from any metal objects, any magnetic interference. So we can see that the data is rotating on there. So in the data also we show that it got more than 1000 samples for now with a compass 1 error 0.01. We need it to get all the data. You can see there's 3 dots over there and sometimes it show more than 5 dots. So you need to get all the data. Hit all the dots. Aim for the white dots, you say in the notice. So I'll just turn it around. Okay. Here. Again. Do it like this. Maybe at this stage we can pause this video. Later after finish we can continue. It may take a long time. Okay, so now after a few minutes we get notice here new offset for compass 1 is -253, -60 and -44. This have been saved for you. It's okay, just click OK for this for now. Alright, we put our flight controller here. So now next is radio calibration process. We go to radio calibration process. Okay, this is the most interesting. We can see the data signal sent from this flight controller to that ESC. So we'll do the calibration radio here. Click. Okay. So at this stage we need to move all the stick to maximum values. This is the throttle. This is the aileron roll. So aileron is reverse, right? So we need to click here. Okay. Okay. So this is the pitch and this is the yaw. Okay. This is the switch. Right. So the other switch is not connected. We only connect to 1 to 5. So this is 1, 2, 3, 4, 5. Right. So when we done, click when done. Okay. Show notice there. So we'll go to the flight modes as in 17F. So this is manual. You need to change or set the flight modes to manual, stabilize and loiter. So manual, this is stabilize, it is preset there, and loiter. Okay, again, top switch is manual, middle switch is stabilize, bottom switch is loiter. Okay, save modes, complete. Okay, so we'll check at the HUD. Go to HUD. So we now go for the step 18. Go to HUD and check the flight modes on the bottom right screen. Here, So this is manual. Middle button is stabilize. Middle button, bottom is loiter. Okay, we can switch the flight modes. Satellite receptions. Okay, you can see satellite reception is 0 over here, as we are now in a room. So we didn't get any satellite reception in a room, right? In a building, so it's hard to get satellite reception because of the interference and blocking of satellite receptions. Compass directions. Okay. So you can see this is the compass, this is the direction of the compass forward. So it's showing that we are okay, easier to show. This is south. So when I turn 90 degrees, this is east, this is north. You can see there north, and this is west. Almost to the west. Okay, west. Altitude and airspeed. This is the altitude. For now it's detected for 4.78 meters. We don't have any airspeed for now. It's not. We are not connected to the pitot tube yet, but we will show it later. And you can see this is the artificial horizons. This is for presenting the air, while this is presenting the ground. So when you see, if we roll the aircraft to the left, so it will show that the actually is changing. Okay, to the right, pitch down, heading to the ground, pitch up, heading to the sky. Okay, so this is very interesting software for you guys to learn. Okay, and then we can try to arm the system. Let's see if we can arm the system. Push the left stick to the right for 3 seconds. So now this is disarm, so we'll try to arm it to the right. Okay, so it doesn't want to arm. Okay, right now it just start to arm. Okay, I thought it doesn't want to arm just now. So it's now armed, so we can turn on the motor in this step. So we want to disarm, we just push it to the left, the stick, so that it will show this arm in the HUD. So what is it's mean by arm and disarm? If it's armed, so the motor will run. If it is disarmed, the motor will not run, so the voltage will not go to the ESC. So the flight controller is controlling the power. Okay, so this is how we calibrate the flight controller and how the system works and how the mission planners is used to calibrate the flight controller. So this is the basic step, but and it is almost complete step. You can try it by following our instruction here. So in the next video we will go through the integration of flight controller into the airplane, and we'll see the experiment that we can run outside the lab.